Stargazers can see through residue and gas mists with this reach, which gives us a better perspective on the world in general. The recommended telescope would be greater than 4 meters across and would work in a turn past the moon. Space experts would be capable of looking significantly more profound into space and sorting out what occurred before. Because of its powerful features, this would give us a much fuller image of the world as we probably are aware of it now. The best picture ever seen was recently taken by the James Webb Telescope. Accompany us as we find out more about the James Webb Telescope and how it could make everything different. How it all started. After the telescope was first proposed in 1996, 3 groups of researchers and architects from public and private sectors came together to see if NASA could actually build the telescope. All 3 teams came to the same conclusion: the telescope could be built. In 1997, NASA agreed to fund more studies to work on the technical and financial requirements. By 2002, the organization had selected teams to construct the telescope's most essential equipment, as well as an advisory group of scientists to assist with the building process. The telescope was officially named the James Webb Space Telescope that same year to honor the former NASA administrator who made significant contributions to the Apollo program's development. When specialists and researchers started building the Webb telescope in 2004, they had to develop new technologies and techniques to meet the mission's strict scientific requirements. Astronauts could repair and upgrade Hubble from Earth, but Webb would need to do all of its work from far beyond Earth's support range. Despite these challenges, the team completed all 18 mirror pieces and put them through extensive tests to ensure they met the standards. It was finally possible to envision the telescope heading into space to accomplish its work. The James Webb Space Telescope was constructed from 2012 to 2013. Different parts of the telescope were built in various locations around the world. Construction began on Webb's sunshield layers in 2013. These layers protect the telescope from excessive heat, allowing it to function well in space. Over the next few years, Webb's various scientific instruments underwent intense testing with high temperatures and vibration. Simultaneously, the telescope's 18 individual mirrors were carefully placed onto its backplane structure. These components were assembled and tested at NASA's Johnson Space Center in Houston, Texas, in 2017. The telescope and its equipment also underwent a final round of environmental tests in a massive thermal vacuum chamber to ensure they would function properly in space. Webb was finally launched into orbit around Earth on December 25, 2021, at 7:20 a.m. Eastern Standard Time. How it works. So, how does the telescope actually work? People often make space exploration sound simple, so at first, it may seem like just another camera. However, it's entirely different, which is why it took so long to go from concept to launch day. The James Webb Telescope is a powerful infrared telescope designed to observe objects in space that are too cold or faint for regular telescopes to detect, things like stars, galaxies, and planets just beginning to form. The telescope is designed to capture infrared light, which is what these distant celestial bodies use to emit most of their energy. This allows us to learn more about them. Infrared light cannot penetrate gas and dust, which makes it look cloudy to our eyes. However, Webb can detect bright radiation, visible light, and infrared radiation. This enables it to capture images of objects hidden by dust and gas, providing us with a better view of distant events in the universe. It is also possible to study the properties of objects like their chemical composition and temperature using infrared light. Infrared light is useful in many fields of physical science and technology. It can help us learn more about how stars, galaxies, and other cosmic objects form and evolve over time. It can also detect signs of chemical pollution in our atmosphere. The telescope is equipped with a large array of mirrors, advanced imaging and spectroscopy tools, and cutting-edge thermal control systems that allow it to operate in harsh conditions like space, which, as you know, is extremely hostile. Since this camera is designed to operate autonomously in space, it had to be built to withstand anything it might encounter out there without any assistance. After the telescope was launched into space and separated from its launch vehicle, it unfolded and began its long journey to its destination, following a complex series of steps along the way. There were several critical stages in this process, such as passing the moon and separating into various components. The telescope became one of the most powerful instruments of its kind as soon as it was fully deployed. How it got to space. Let's look at the steps this groundbreaking telescope took to reach space before discussing why it's so significant. The launch was the first necessary step. The solar array was deployed after launch. 2 special pallets were deployed on the 3rd day of the journey while the spacecraft was still occupied. The primary sun shields for Webb were stored on these pallets. These shields keep the telescope cool and enable it to function properly in space. Deploying these shields was essential for ensuring that the camera could operate effectively during its mission. On the 4th day, the tower holding the instrument package was moved to its final position and assembled. There were many complicated steps in this process, but everything went smoothly because of the telescope's meticulous design. The momentum flap was then raised, allowing solar pressure to stabilize the telescope. Next, the sunshield layer cover was released, unveiling the tennis court-sized sunshields. Once everything was in place, the sunshield and mid-booms were deployed. The 5 layers of the sunshield were then separated. But this wasn't the end. After being placed in space, the James Webb Telescope had to go through numerous critical steps. On day 10, the secondary mirror and a frame to hold the smaller mirror were positioned, and the main mirror wings were extended out on day 13, which made the telescope its standard and shape. After these steps were done, the telescope was prepared to begin its occupation of taking a gander at stars and planets far away. What is the genuine point? What's fascinating about the James Webb Telescope is that it wasn't exactly made to do only one thing. A considerable amount of things ought to be addressed by it. How about we look into this some more by traveling once again into the past? Researchers, like Daniel Einstein, a stargazer at the Harvard-Smithsonian Center for Astronomy, can utilize telescopes like the James Webb Space Telescope to travel once again into the past and see universes when they were simply beginning to form. Light moves gradually, so a planet that is far away looks older than it actually is. The telescope can take a gander at the early history of galaxies to learn how they formed and changed over time. Since it can see worlds so far away, researchers like Einstein can get a full picture of how galaxies form and evolve by examining various worlds at different stages of development. Webb is perfect for studying faraway galaxies because it can see infrared light. The universe is expanding, which stretches the light from these galaxies over time, changing the color of the light from visible or ultraviolet to infrared. Webb is very adept at capturing infrared signals since it is both large and cold. This allows it to see much farther into space than other telescopes. It makes it possible for Webb to observe galaxies as they grow and evolve, taking pictures of how they change over time. This helps us learn more about how galaxies form and develop, thanks to Webb, which assists us in understanding the universe better. All in all, gathering what we know, scientists look at stars from the exact place where they were born. Stars are formed from dense clouds of gas and dust, called stellar nurseries. Because these clouds are so thick, visible light cannot penetrate them, making it hard for scientists to use regular optics to study these regions. However, infrared light can pass through the dusty clouds more easily than visible light, allowing researchers to see into the heart of these star nurseries in a way that was previously impossible. Since the Webb telescope can see infrared light, researchers will be able to study these areas in much greater detail than before. An infrared astronomer at the University of Arizona named Maria Smell is the principal investigator of one of Webb's cameras. She explains that this is because red light has a longer wavelength and can travel through the dust in our atmosphere better than blue light. Additionally, infrared light can penetrate deeper into dusty galaxies than visible light. This effect is similar to why the sun appears redder at sunset than during the day. Since it can detect infrared light better, Hubble has only been able to study the formation of stars on a surface level. However, the broader range of infrared bands on Webb will enable researchers to see further into the dust and learn more about how stars are born and develop. Seeing black holes is challenging since they can trap light, making them among the most mysterious phenomena in the universe. On the other hand, we can observe the effects of black holes on the stars and galaxies around them. Researchers have been able to study different aspects of black holes using telescopes like X-ray telescopes. For example, they've studied how the violent shredding of nearby stars heats the area around black holes. With the launch of NASA's Webb Telescope, its infrared equipment will allow researchers to learn more about black holes. They can delve deeper into black holes and the complex physics that occur near them by observing the cooler gases and stars swirling around them. Researchers continue studying black holes, even though they aren't visible, and they remain a crucial area of study. When observing stars in dense, dusty parts of space, seeing them can be difficult because the dust obstructs the view. However, since Webb has a strong ability to see in the infrared, it will be able to peer through this dust storm and provide researchers with valuable data about where stars are located. By analyzing the mass, size, and behavior of these star-hungry black holes and examining their temperatures, velocities, and chemical compositions, we can learn more about the fundamental processes that drive galaxy growth and transformation across the universe. Ultimately, this information will help us understand how stars like our Sun formed and changed over time, offering answers to questions we didn't even think to ask. Life in other worlds? The James Webb Telescope can find chemical signs of life in the atmospheres of other planets by analyzing infrared colors. Some of these signs are chemicals that make a place habitable, like carbon dioxide and oxygen, which are produced by living processes, such as photosynthesis. Researchers can look for signs of life on other worlds and determine if they might be habitable. Concentrating on these synthetic substances, Webb can track down the chemical signatures of significant living molecules like methane and water, which could mean that there is life on other worlds. Webb's highly sensitive instruments will also allow scientists to learn more than ever before about the atmospheres of these powerful worlds. Overall, this incredible new camera is going to fundamentally alter the way we think about the universe and might even help us find evidence of life beyond Earth. The Webb Space Telescope is very powerful and has two instruments that will help scientists study clusters of infrared signals coming from worlds beyond our solar system. Researchers can learn a lot about other worlds by using this data to identify what chemicals are in the atmosphere of an exoplanet. Exoplanet science is still a fairly new area. The first exoplanet was discovered in 1992, which was a huge step forward. Since then, scientists have discovered thousands of new worlds in the universe. Many of these planets have strange features that we don't see on Earth. Exoplanets are very distant worlds that humans have only recently learned about. With current technology, we don't know a lot about them, but we will be able to study these exoplanets much better with new space telescopes like NASA's James Webb Space Telescope. We can also learn more about their characteristics. Webb is designed to operate in space, where it can observe infrared light without being affected by Earth's atmosphere or surface radiation. This differs from observations made on Earth, which are limited by our environment. Many new and significant discoveries have already been made, and many people are already talking about how impressive the James Webb Telescope is. Let's take a closer look at some of the most important ones. The goal of building the JWST was to find worlds that orbit stars other than our Sun. JWST has been able to directly detect light from exoplanets using various unique methods, showing that this feature is functioning well. One example is its ability to take images of Jupiter-class planets, like HIP 65426, using the transit method, which observes the planet as it moves in front of its star and blocks some of its light. Alongside this method, the JWST has also shown that the atmospheres of two exoplanets about the size of Jupiter contain water and carbon dioxide. These discoveries demonstrate that the JWST is performing exceptionally well, enabling us to study exoplanets in more detail and with greater precision. Overall, these results show that the JWST can not only study planets beyond our solar system but also provide us with a wealth of information we could only hope for before. The Doppler effect also has an impact on cosmic observations, particularly for galaxies that are very far away. Astronomers observe objects in the universe that are farther away and see light that has been stretched to longer wavelengths. This effect, known as the Doppler effect, occurs because the universe is expanding. NASA built the James Webb Space Telescope to take advantage of this effect. It can detect the universe's oldest galaxies, which formed just a few 100 million years after the Big Bang. Astronomers may now be able to study the early beginnings of the universe's history. After their first observations, the JWST has already discovered many potential galaxies from these early times. With this telescope and other cutting-edge technologies working together, we may be able to answer questions that were once thought to be too difficult to even attempt. One stunning example of JWST's power is its clear image of Neptune's rings. We discussed how the James Webb Telescope recently took the best picture ever. Now that we understand how the telescope works internally, let's talk about the image that has scientists in awe. The James Webb Space Telescope just captured the clearest picture of Neptune's rings ever taken. These rings hadn't been seen in such detail since NASA's Voyager 2 mission captured an image of them more than 30 years ago. Webb's cameras not only revealed the icy planet's bright, narrow rings but also showed that these rings consist of millions of dust-sized particles that scatter light in various ways. The high-resolution image of Neptune also provides insights into the planet's complex atmosphere, like long bands of clouds and intense storms. Scientists are still studying these features to learn more about how the planet's atmosphere changes over time. Webb is not only a remarkable tool for studying the universe, but it is also a powerful tool for studying planets far away, like Neptune, which have atmospheres and weather patterns that scientists can study to learn more about weather on Earth. Webb will profoundly influence how we think about planetary systems across the universe and beyond because of its high resolution and sensitivity. We can't wait to see what new discoveries it makes in the years to come. What do you think of the James Webb Telescope's ability to advance science? Please share your response in the box below. If you enjoyed this video, give it a thumbs up. See you in the next one.